projectiles. Today we're talking about projectiles. So we're right here. We're on page 5 of your note packet. You're on page 5 of your note packet. Okay. Mr. Urban, there are filled out notes copied up front. Thank you, ma'am. Okay. So today we're talking about, and I know it's really day 3, but I'd already printed the notes. So application of quadratics, we're doing projectile motion. I want everyone to pick their head up. It is not nap time. So the function f of t equals negative 5t squared plus 20t plus 60 models the approximate height of an object t seconds after it is launched. The first thing that we need to do is draw a diagram. Well, I want you to remember that this f of t, this function that we're looking at right here, is no different than saying y equals negative 5x squared plus 20x plus 60. So tell me, if I were to draw a diagram of this, what is one thing that you know about this? Like maybe where does this graph start? Where does it cross the y-axis? What is the initial value? When I say words like that, what am I referring to? Where does this graph start? Where does it cross the y-axis? What is the initial value? God bless you. Where does this cross the y-axis? Say again. Anyone know? What's the y-intercept? It's on your journals, the blue one. The y-intercept is 60. Good job. The y-intercept is 60. So I'm going to just draw a y-axis and an x-axis. And I'm going to put a mark right here. And I'm going to say that this is 60. Because I'm really trying to draw neatly for you. So I have this projectile that goes up in the air. It starts right here. It's going to go up, and then it's going to come down and hit the ground. Okay? That's what our sketch looks like. When I first start, this x-axis down here, this is my time, right? It says the t is time in seconds. So when I first start, my time is 0. And that makes sense because I cross the y-axis when x is 0. So this is when I first start. So this is really the ordered pair 0, 60. Okay? So it says, how long does it take? How long? That means I'm looking for the t value. How long? That means I want to find t, which is my time, which is really the x-axis. Okay? How long does it take for the object to reach its maximum height? Where does the maximum happen on a parabola? When you see the word maximum, where does the maximum happen on a parabola? At the highest point? What's that called? The vertex. When you see maximum, that means, hey, you need to look at the vertex. That's going to be right here. So we're trying to figure out this time. Well, what is that dashed line that I just drew? The AOS, the axis of symmetry. So that's really what it's asking you. It's asking you to find the axis of symmetry, which is the opposite of B over 2A. Well, what is the opposite of B? What is the opposite of B, Bailey? What's B in that function? What is the opposite of B, Braden? Negative 20. Thank you. Over 2 times, what is the value of A, Aiden? Okay. So I really end up with negative 20 over what? Yeah, what is negative 20 over negative 10? Equals 2. So x equals 2. meaning that it takes how many seconds for it to reach its highest point? Yeah, that's what it's asking me. So this time right here is at 2 seconds. So it takes 2 seconds. All right. How many seconds does it take for the object to reach the ground? Well, where is the object reaching the ground? This point right here. This is where it hits the ground, right? So I'm trying to figure out that time. Well, what is that point? What is that point? What is that point called? That green dot that I just put on the graph is called a what? A root or a solution. How do I find a root or a solution? Well, I take my function, I set it equal to 0, and I solve by factoring. Okay, so 0 equals negative 5t squared plus 20t plus 60. What is the number one rule of factoring, Caden? What's the GCF? Negative 5. I'm going to take a negative 5 out of everything, dividing everything by negative 5. So 0 equals negative 5 times, let's see, that gives me t squared minus 4t minus 12. So what two numbers can I multiply together to get negative 12 that when I add them, I get negative 4? What two numbers give me negative 12, negative 6, and positive 2? Okay, so t minus 6 times t plus 2. Well, if my factor is positive, what is my time going to be, or my root going to be? Negative. What does the time of negative 2 seconds look like? It doesn't. We don't have a time machine. We can't travel backwards in time, so we can't go backwards in time. The factor t minus 6 means that my actual solution is positive 6. So this crosses the x-axis, or it hits the ground at 6 seconds. Hits the ground at 6 seconds. Says, what is a practical domain? So typically when we think about quadratic functions, we say that the domain is all real numbers, right? However, can we have negative time? Does that make sense? No. And once it hits the ground, what happens? Is it still moving? No, it stops moving. So it really just, it only has a range of time that it can be our domain. When does it start and when does it stop? It starts at what time and it stops at what time? Ashton, what time does this application start? We put it up at the graph. What is the t, the first t number we put up there? So it starts at 0 seconds. It starts at the very beginning. So the domain, well, it starts at 0, and that has to be less than or equal to, remember your domain is an x value. And when does it end, Uriah? When does it hit the ground? At 6, less than or equal to 6. That's a practical domain. It can't go past that, right? Because it's already hit the ground. Does that make sense? Okay. We're going to do another one. An object is shot from ground level with an initial velocity of 64 feet per second. Its height after t seconds is given by this function. So remember that the t, the time in seconds, is going across the x-axis. Like that's what x is really counting. So since it starts at the ground, when I think about what my sketch is going to look like here, my sketch is going to be something like this. It starts, it goes up, and it comes down. Okay, that's what happens here. So it says, question A, what are the independent and dependent variables? Well, this is my height right here. My y-axis represents my height. And my x-axis is my time in seconds. So think about when you learned about independent and dependent variables. Independent variables. Does the time depend on the height, or does the height of the projectile depend on how long it's been in the air? Yes, thank you. The height depends on the time. So the time, which is the x, and x is always independent. So x is the independent variable. It's time. So independent is time. And the y, which is the dependent variable, what does the y stand for? What's the y-axis standing for? The height. Okay. How long, meaning how many seconds, does it take for the object to reach the maximum height? That's this right here. But I'm wanting to know after how much time. I'm not wanting what is the maximum height. I'm asking how much time does it take? What am I asking to be find? Probably exactly the same as the last one. What are we finding there? We're finding the time. What does that dashed line represent? Axis of symmetry. X equals the opposite of B over 2A. So what is the opposite of the B term? Well, let's look at this function really fast because it's not written in standard form. So how can I put this function, h of t equals 64t minus 16t squared, into standard form? Standard form, the largest degree comes first. It's a quadratic. The squared term has to come first. So what does that look like? Yep. Plus 64t. So what is the opposite? What is the opposite of the B term, Bailey? What is the opposite of the B term? I didn't hear you. Bailey. AX squared plus BX plus C. So what is the middle term, the B term? Negative 6. Are you saying negative 64? Negative 64. Over 2 times. Hayden, what's the A term? Okay. Delilah, what is 2 times negative 16? I didn't hear you, hon. Okay, thank you, ma'am. Lorenzo, what is negative 64 divided by negative 32? You have a calculator. Use it. What do you get? 2. So x equals 2. So that means it takes 2 seconds to reach the maximum height. So this time right here is at 2 seconds. T equals 2. What is the maximum height? How do we find that? How do we find the maximum height if we know what the x value is when it happens? Well, we take that x value and we plug it into the function. So the maximum height happens when x equals 2, and that equals negative 16 times the time, which is 2 seconds, squared, plus 64. I know that's kind of smashed together. I'm sorry. That's the best I can do right this second. Times 2. So I need someone to pick up their calculator and take negative 16 times t squared. Negative 16 times t squared plus 64 times 2. What do you get, Tiana? You get what? Go ahead, Violet. No, you don't get negative 64. You get a positive 64. So the max height equals 64 feet. Yeah. How long does it take for the object to hit the ground? What's that asking me? When I hit the ground, what's it asking me? It's asking me for this time right here. What is that time representing? The X what? I can't hear you, honey. Nope. Say it. The x-intercept, which means we have to set it equal to 0 and solve by factoring. 0 equals negative 16t squared plus 64t. How am I going to factor this? First thing I would do is look for a what? GCF. Is there a GCF here? Yes, negative 16t. I can take out a negative 16t from both of those. So that gives me 0 equals negative 16t times t minus 4. T minus 4. No, it's not squared because t times t is t squared. And 16 times, does that make sense? Do you see that, hon? Okay. So let's see. If negative 16t equals 0, what is t? If negative 16t is 0, Gianna, what is t? It's 0. Good job. If t minus 4 equals 0, Uriah, what is t? No, it is not negative 4. Huh? Positive 4. So when does it hit the ground? At 4 seconds. Hits the ground at 4 seconds. It starts at 0 seconds. Well, that's exactly how we drew it. That's exactly how we made our sketch. It starts at time 0 and it hits the ground at time 4. What is the practical domain for this problem? What is the practical domain? Less than or equal to x. Keep going. Is less than or equal to what? When does it hit the ground? 4 seconds. There you go. What is a practical range? Range is your y variables. Well, it starts right at the ground, right? It starts on the ground. So that's 0 is less than or equal to y. What's the highest it goes? Yep, less than or equal to 64. That's your practical range. Okay. All right. Number 3, the expression negative 4x squared plus 8x plus 12 represents the height of a coconut thrown from a person in a tree. So here's this person in a tree, and they're throwing this coconut, right? So I actually drew a picture of a fabulous like palm tree on the worked out notes, but I can't do that here because I don't have a good pencil. So they're throwing this coconut. How high are the people in the tree when they throw the coconut? What's the y-intercept? 12. They're 12 feet in the air when they throw this coconut. They're 12 feet in the air when they throw the coconut. Okay. It says, rewrite the expression to reveal linear factors. It just means factor this. Well, if I want to factor this, the first thing I'm going to do is take out a negative 4. Do you see I'm taking out a negative 4 from every single term? So negative 4x squared divided by negative 4 is x squared. 8x divided by negative 4 is negative 2x. 12 divided by negative 4 is negative 3. I have to factor this. How do I get my factors? Two numbers that multiply to negative 3 that add to negative 2. Well, that's negative 3 and positive 1. So my factors are x minus 3 times x plus 1. Those are linear because they're degree 1. Those are my linear factors because they're degree 1. It says identify the zeros. Well, if x minus 3 is one of my factors, if I set it equal to 0, then one of my roots or zeros is 3. If x plus 1 is the other factor, then x equals -1. Remember that this is time. This is time. So what does this mean in terms of my question? Yeah, it means that if you guys think along the x-axis, this is where -1 lives, right? Here, let me fix that. Think in terms of the x-axis. If you think about the time, this is -1, this is 0 where it just starts, and this is 3 where it hits the ground. So this is 1 and 2. That's what that looks like. But do you see how when I extended my parabola, I made it a dashed line? This is a dashed line right here because it starts in the air. It starts up at 12 feet. Now your parabola really does continue this way, right? I mean, it's not cutting off the parabola. We just don't care about what happens when the x values are negative because we can't do negative time. So it means what? So it says, what does it mean in terms of the problem? It just means that it hits the ground at 3 seconds. Hits the ground at 3 seconds. It says, well, how long is it in the air? 3 seconds. How long is it in the air? 3 seconds. I'm going to freeze this for 1 second, and I'm going to pull up a Desmos and graph that because I want you guys to see what's happening. So your function, really, if you think of it in terms of a function, y equals 4x squared. It was negative 4x squared, sorry. Y equals negative 4x squared plus 8x plus 12. Here's what this graph actually looks like. So this right here is -1. We don't care about -1. And this is where it starts. It starts at 12. So the part that we see, the real world part, is it starts at 12 and it goes up to a maximum height of 18. Sorry, a maximum height of 16. And then it comes down and it hits my x-axis at 3 seconds. We just care about the positive x time, but it really does continue on the left. We just don't look at that, okay? That's what's happening there. Number 4, we're almost done with our notes. Number 4, Kelly hit a volleyball into the air with an initial velocity of 24 feet per second. The height, h, in the feet of the ball above the ground can be modeled by h of t equals -16t squared plus 24t plus 3, where t is the time in seconds after Kelly hits the volleyball. Find the time it takes for the ball to reach 12 feet above the ground. Well, we're going to use Desmos for this. We're just going to graph this in Desmos. So I'm going to split my screen, and we're going to do half computer, half Desmos. So I'm going to put in this function, -16 t squared. Can someone, I'm going to change it to x's. Can someone read the rest of that for me since I have it blocked? Plus 24t. Plus what? Plus 3. Thank you. Okay, so here is my graph. Here's my graph. The question is, when will the graph, or when will it reach a height of what? What's it asking you? When is it going to be at 12 feet? So y equals 12 is what kind of a line? It's a horizontal line. So y equals 12 right here. This is where it hits 12 feet. I need to know the time. So that's this ordered pair. So what is the ordered pair when it hits 12 feet? Can you guys see that? It's 0.75. It's 0.75 seconds. 0.75 seconds. So it hits 12 feet. The ball is 12 feet above the ground at 0.75 seconds. That's all that question's asking you. What time does it hit the ground? At 0.75 seconds. Okay. The next one says, hey, the function h of t equals negative 16x squared plus 35x plus 6 describes the height and feet of a tennis ball x seconds after it is shot in the air from a pitching machine. Well, the ball is 6 feet off the ground when it starts. So it kind of goes like this. This is the 6 feet mark. So it says evaluate what happens at h of 1.5. Well, that just means take your function. That just means take your function and let the time equal 1.5. So h of 1.5 equals negative 16 times 1.5 squared plus 35 times 1.5 plus 6. So put that into your calculator, just like that. Negative 16, parenthesis, 1.5 squared plus 35, parenthesis, 1.5, parenthesis, plus 6. 22.5. So what does this mean? It says interpret the meaning of this ordered pair, or this point. Well, it means at 1.5 seconds, the tennis ball is what? What does the 22.5 represent? That's the height in the air. So the tennis ball is 22.5 feet in the air. Okay, the tennis ball is 22.5 feet in the air.